Hey P4, here's your little review movie for measurement around length and time. We've been using these kind of stairs to help us with our metric conversions. It goes kilometer, hectometer, decameter, meter, decimeter, centimeter, millimeter. I put these boxes here for the really ones that are probably the most important ones, obviously, milli, centi, and kilo. The mnemonic to help you remember it could be something like King Henry died Monday drinking chocolate milk. I'll put these blank steps somewhere on the test for you to fill in to help you out. As you go down the steps, though, the units that you're measuring get smaller, but the actual numbers get bigger, and vice versa on the bottom. And we have some common conversions down here that you might be good to just know that quickly in your head. For perimeter, a definition might be something like it's the distance that you could measure that's around an object or a shape or something like that. And to calculate the perimeter of a polygon is just any geometric shape. You kind of just add all the lengths together. To calculate the perimeter of a rectangle, the formula could be something like length times width plus length times width, or 2 times length times width, or something like that. And if you're lucky enough to be working with a square, you know it's the 4 widths. So if you know the length of one of the sides, you can figure out what the perimeter is. Okay, so one of the things you need to know for the test is which unit would you use for different distances. For example, you would use kilometers if you were measuring from Ottawa to Toronto, for example. But the distance from our portable to the office, you might use meters. There's the only one where you've kind of got some kind of play with how tall are you. Basically, you would probably use some kind of meters, centimeters, something like that. But if you were measuring just your workbook, you would use centimeters. If you're measuring something super small, you would measure like an ant, you would use millimeters. And how tall the portable is, I'd probably use something like meters for that. Okay, so here's some questions that you might use, you might see on the test for conversions. Let me get a nice pencil going here. Okay, how about something like that? Okay, so if Mr. M, his feet are 29.6 centimeters long, how many millimeters is this? That is one step to the right from centimeters on the steps from centimeters to meters. So that means that you would have this decimal is going to end up moving one space this way. So that's going to end up with a total of 296 millimeters. The next question talks about going from meters to kilometers. That is really 3 steps to the left up the stairs. So if the decimal actually lives here, I've got to go 3 steps to the left. 1, 2, 3. And that would give me an answer of 2.345 kilometers. And then the last question has to do with Daniel throwing a ball. And he's going from meters to centimeters. That's 2 steps from meters to centimeters to the right. So the decimal lives here, 667.2, 2 steps this way. Means I have to insert a 0 in there, and I get 6,720 centimeters, or 67,200 millimeters in the second half. If you see a perimeter on a grid like this, you could just tick off the different spots to figure out what the perimeter is for different shapes. These 2 shapes both happen to have a perimeter of 12, even though they're different shapes. Here's an interesting little triangle where you've got a distance of 1 and 1, but let's zoom in a little bit. The distance from corner to corner, it's not actually 1, this distance here. So that's why the distance here is actually 1.4, just so you know that. And therefore, this shape might have a perimeter of 1, 1, and 1.4 of 3.4. Just keep that in mind for some triangles and things like that. Again, for this irregular shape, you just count off the ticks to figure out what the perimeter would be. In these types of questions where it says measure the perimeter, you can just use your ruler and measure the perimeter. These 2 shapes are regular polygons, so that if you know the the length of this side, you probably could calculate it 5 times. And for a star, if you know the length of this side, you can multiply it by 10, and you'll figure out the whole perimeter. There are a number of questions in the book about pictures and frames and things like that. Here's a typical one. You've got a frame around the outside of a picture, and that frame, in this case, is 10 centimeters. So it's 10 centimeters here, 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 and here. And then you've got the dimensions of the picture, 15 by 20. So to figure out the perimeter of this whole thing, you kind of have to break it down into the different sections to figure out how wide and long it is. So what I usually do is make little ticks here to show that, well, from here to here is 10 centimeters from the border, here to here is 20 centimeters, and here to here is 10 centimeters. And that gives this a total of 40 around the outside. Now you can do the same for the bottom as well. Once you know the perimeter of the sides, you can calculate what the perimeter is of the whole picture, including the border. In this chapter, they introduce just a little bit of the circumference of a circle. All you really need to know is that, and we figured this out by measuring different shapes, is that when you look at the width of the circle, the circumference ends up being about a little more than 3 times that. And if you know a little bit about pi, you can figure out why that would be. But as long as you know the width, then you should be able to figure out the circumference. Also, if you know the circumference, you should be able to go backwards and figure out the width. Okay? Okay, so now we're going to talk about the elapsed time questions. We spend a significant amount of time doing these kind of questions. We start out when we talk about elapsed time with everyone looking kind of nervous and quiet, and hopefully by the end of a number of days of talking about it, things got better. I find that if they give you a start time and a finish time, and they're asking for elapsed time, I always make some kind of a timeline. One more time. If they give you the beginning and the end time, make some kind of timeline of some sort. This one's fairly easy. 7 a.m. in the morning all the way to 11. And I just wrote out the numbers. And each one of these humps, pardon me, represents an hour elapsed. So this one turns out to be 16 hours. Here's another question about elapsed time where they're giving you the hour and the minutes, and they're giving you the start time and the end time. So when they give you start and end, I always end up with doing a timeline for these type of questions. What I do is I write down the start time here, and then I try to figure out, I do a calculation only on this end, where I try to figure out how many minutes do I have to add to this to round it up pretty well to the next hour. So it turns out I have to add 25 minutes here to round it out to the next hour to get to 12 o'clock in this question. Then I'm at 12 o'clock. I can just easily go along counting hours until I get to 2 o'clock, which is the hour of that this activity finishes at. And then I just add the 17. I don't calculate at this end, but I do a calculations here to figure out how many minutes I have to add to get up to the next hour. Then what I do is I take the 25 and the 17 and I add them together. This time I'm lucky, it turns out to be 42. If this number is greater than 60, then later on I'm going to have to add it to the time. But because it's only 42, then my answer is going to be a nice 42 minutes over here. How many solid hours did I count? 2 hours. So the answer would be 2 hours and 42 minutes with a nice sentence going on down here. Here's another question where they give you the starting time. They don't give you the end time, but they tell you how long the thing took. So when they don't give you a start and a finish, I find that timeline doesn't work as easily this time. Instead, I'm going to use this like an adding question, but I need to be careful when I'm adding seconds and minutes, of course, because it only really goes up to 60. So if I'm starting at 2 hours, 39 minutes and 45 seconds, then I'm going to start with the seconds first of all. The duration is 23 minutes and 7 seconds for this activity. I'm going to add the 7 seconds onto the 45. So 45 plus 7 is 52. Again, this is a nice easy calculation, and the number doesn't go beyond 60, so I don't have to do anything. The final answer will have 52 seconds in it. Then I'm going to go to the minutes. I have 39 minutes plus 23 minutes for the duration of the activity. Sorry. And I end up with 62 minutes. Now this time it is greater than an hour. So 62 minutes is really 1 hour and 2 minutes. So instead of the 2 o'clock that I start with, I'm going to have to advance it to 3 o'clock because I've got an hour when I calculate all the minutes. So the final time would be 3 hours, 2 minutes, and 52 seconds.